We are organizing the conference called Ziehl, as Future and Innovation of Superconductivity in the in power applications in the energy market. And this is already the 8th conference, so since 14 years now we are doing these conferences. The first time here in Berlin in the Berlin-Brandenburger Academy of Science, and with about 100 people. The general aim of the talks really changed from really technical feasibility, reliability of superconductivity, and always questions if superconductivity is reliable, if technology is feasible, if the material is there, and now we are really talking about how to bring this into the market. And the interesting thing for this conference, for example, was that maybe we don't need additional money, we just need deregulation.
We are now discussing applications. We are now discussing how can we bring superconductivity into reality, into the market, into industry and into the grids.
The Ziehl workshop is a perfect place to reflect on all the advances in superconductivity, especially in Germany, especially in the funded projects we have here, and to discuss these projects and these developments in the framework of recent trends and developments in the society and needs we have in our energy systems.
So we are developing a superconducting heater for heating aluminium and copper billets in order to be formed into profiles, and in particular with the recent situation and the shortage of gas, there is a large pressure to switch from conventional heating systems based on fossil fuel to modern electrical systems, and there are two options, so the inductive heater and the superconducting heater, and obviously the superconducting heater is much more efficient and offers much better quality.
Wir haben in München ein Projekt Supraleitung aufgelegt. In diesem Projekt prüfen wir, ob der Einsatz eines Supraleiters als Ersatz für die vorhandene Kabeltechnik möglich ist. Es geht uns vor allen Dingen darum, eine innovative Technik einzusetzen, die wir heute gegenüber den vorhandenen Gasdruckkabeln verwenden können, denn die vorhandenen Gasdruckkabel müssen in München in den nächsten Jahren ausgetauscht werden. Da bietet sich natürlich eine starke Lösung wie ein Supraleiter an, wo man nur gegebenenfalls ein Kabel verlegen muss. Im Gegensatz dazu, wenn man herkömmliche Kabel verlegt, müsste man 5 Kabel nach heutiger Lesart verlegen. Und das würde natürlich sehr, sehr viel stärkere und längere Beeinflussungen für die Bürger bedeuten. Sehr viel mehr Verkehrslärm, sehr viel mehr Stau, sehr viel weniger Zugänglichkeit von Gehwegen, Straßenteilen und Ähnlichem. Gleichzeitig würden wir natürlich sehr viel mehr Umwelt, Lärm und so weiter produzieren. Und das kann man alles mit einem Supraleiter, der noch dazu mit Stickstoff, einem Hauptbestandteil der Luft, gekühlt werden kann. Das würde man natürlich mit dem Supraleiter vermeiden können.
My topic at this conference was in the field of liquid hydrogen and high temperature superconductivity in the energy system as a whole. And the big advantage there is if you have to import hydrogen as an energy carrier, then the best way is to do that in a liquid shape. And when having such a liquid, it has a low temperature and is a perfect habitat, a perfect biosphere, so to speak, for high temperature superconductivity.
The geography of Europe just means that a lot of the decarbonized energy is going to come from the sea, so it'll take a while to put superconductors in the sea, but we aim to do so by about 2030. So we really see this for power corridors, north-south, between countries, linking up grids as part of grid development as a whole.
We believe that the energy sector and everything will grow up enormously. Namely now with the crisis in Ukraine, of course, as well, it's becoming more important, and we need to focus on the new sources and clean energy, obviously.
Data centers obviously is only a very small part of the applications possible for superconductors, but I'm convinced that it's the most promising one to go into real life within the next 1 or 2 years, because there's a desperate need to be more efficient in the data center space. To be able to integrate a superconductor into a data center, we looked at the OCP technology, which was open sourced by Facebook in 2011. The main advantage is that the whole server rack already runs on DC energy with a DC bus bar on the back, So it's relatively easy to connect the superconductive busbar to that DC busbar and supply the servers directly on DC technology.
Parliamentary evening, I think it's always a success to make superconductivity known to those guys that are taking political decisions. It's important that they know about superconductivity, but we have to work closer with those people, with the politicians, because they give the outer frame to really make superconductivity successful into the market.
It was a really interesting discussion where we have science on the table, we have people from the industry on the table, and we have politicians, and it was a bit of a problem to get them to understand each other, and so it's pretty valuable because I believe I have understood a lot which I haven't understood before, and vice versa.
Die größten Schwierigkeiten sind, glaube ich, tatsächlich der Übergang aus diesem Forschungsstand, wo wir jetzt noch sind, in den Markt. Ich glaube, das ist einfach die größte Schwierigkeit, weil die Unternehmen natürlich erstmal investieren müssen in die Technik, und da scheuen sich, glaube ich, noch die meisten Unternehmen.
Well, of course, several projects will be hopefully successfully finished. I think, of course, I have the main interest for me is the cable project, and I hope in the next conference we will also see already that the successor, the real cable installation, is on a good way, because this is then in 2024. Yes, it should be. There should be already a bidding process out or decided. So I think in the next conference we will see that those projects led to a real installation which is commercial.
Yeah, I mean, I think superconductors are a nascent technology, but the potential and the prize is so great that I really see some of these things happening slowly and then all at once. So things and discontinuities just happen, and the technology is sitting there ready to go. So yeah, I really see as part of the accelerating green transition that it has a really unique place in the supergrid.
It's always a question of the time frame. If we talk about, let's say, a time frame of the next 5 years or something like that, the magnet applications, the high field magnet applications, will definitely see future developments, but the total amount is not the highest. I'm pretty sure it will lead to a continuous demand of superconducting materials, and with that prices go down, and when prices for the conductor will be low enough, also other applications will come in, and in the very end, if the prices are okay, cable, transmission lines, and all these things will come up.
What we've seen is that superconductivity can be competitive, but actually the TSOs and also the local distribution grid companies are really hindered from implementing new technologies, and that superconductivity is there, and now we really are looking for a interesting future, deregulated, with already very sweet spots where superconductivity can be applied.
Yes, grid operators have a tremendous goal for the next 10, 20 years. In principle, we have to double our electrical grid from what we have installed over the last 130 years. We have to double that within the next 20, 30 years, and that is a tremendous challenge.